What's up, everybody? Welcome back to another video. Sorry I didn't upload the last date that I was supposed to because I was busy. You know how it is during the holidays, before and after. But anyways, today I'll be sharing some information about welding on plastics. Hope you enjoy. Because I'm barely learning about welding plastics myself, I'll just read the information that I've learned directly from the book, word for word. I've got some information highlighted here. So basically this part is saying welding plastic is a fusion process like stick or MIG in steel. The joint is heated to melting point. Then, if necessary, a filler rod is fused into the parent material to fill and reinforce it. When they say parent material, they mean the material that you start off with. Unlike in an arc method, though, the filler does not need to be completely melted. Fusion happens only where the rod and parent plastic meet. So essentially, plastic welding is basically the same as regular welding, just with different materials and different equipment. Uh, Plastic welding doesn't need an arc, unlike regular welding. I guess plastic welding is so much similar to regular steel welding that some of the different principles you have to follow are the same. So like right here it says welding plastics is no different in principle to welding steel. The same four things must be right: the filler rod, the rod angle, the speed of travel, and the temperature. If the work isn't hot enough, then there's little or no fusion. If it's too hot, the plastic distorts or burns. In most cases, smoke coming off the weld says things are definitely too hot, which is the same case for normal steel welding. You gotta have your filler rod be the same material as your parent material or your base metal. Then you have to have the right rod angle, and the right travel speed and temperature. And if the work is too hot for the metal, then you'll obviously burn through a lot. But if it's not enough heat, it won't melt enough, and there won't be any fusion. It says here, most plastics are welded between 518 and 752 degrees Fahrenheit, or 270 and 400 degrees Celsius. Down here, it gives a little bit of information about what types of materials you're working with. So like if you don't know which material that can work with your filler rod, you can do a test run, and if it fuses, you shouldn't be able to pull it off. But if it doesn't fuse, that means it's the wrong material filler rod. Don't know what material you have, make short test welds with different fillers. The rod that won't pull off when cool is the one to use, meaning that it's been fused. Here are some different tests. So the PVC materials are rigid and won't bend easily. Polypropylenes are flexible and show stress marks at the point of bend, and polyethylenes are flexible and show no stress marks when bent. So that's three different materials you can test by bending them and see what they look like. Also says down here that the only compatible fillers will have fused, the others will just lift away. So back to that one test. If you try and break it, obviously if it's the wrong one, it'll break apart easily. But if it's fused, then that means it's the right one. Down here, it gives a little bit of information about the feel that you get from welding on plastics. Unlike arc or gas processes, welding plastic is a very physical job. You must put steady pressure on the filler rod and sometimes the welding nozzle to push it into the joint where it fuses with the hot plastic below. With regular welding on plates, you don't really have to put pressure on the material. You just drag the wire or the rod along the material with very little pressure. Similarly to regular welding, plastic welding has its own method for reconnects. So right here, what's the deal when you run out of the filler rod partway down a joint? The principle is simple. Slice out a notch in the warm, just finished weld, then snip a matching point on the new length of filler. Preheat, the restart area and fuse the new rod into the notch before continuing down the joint. So it's not exactly the same as a reconnect for regular welding, but it's its own method. Here are some pictures that kind of describe how to do it. You can see that they slice out the knot. They slice out a notch, and then they trim part of the new filler rod so that when they restart it, it'll fit together nicely. With regular welding, when you run out of rod or you stop to reconnect, you go about half an inch away, strike the arc, make a little puddle, bring it back, and then run it along. That's pretty much it, aside from basic information, but I do want to show you guys the parts and some of the temperatures that are supposed to be welded with the respected codes for what types of material it is. So here is some equipment used for plastic welding. Here you have your torch or gun, and then you have all your pieces right here. So this would be your nozzle, which goes onto the outlet, and then you have different different extending pieces for different welding processes. So here are two charts. One chart providing code names for the types of materials, and the other chart providing information about the different temperatures for the corresponding code. I'm not going to sit here and try to pronounce all those names, but I'll let you guys look over it. But right off the bat, let's see. The highest temperature for Celsius would be 400 degrees, and the lowest temperature for Celsius would be about 270 degrees. Highest temperature for Fahrenheit would be 752, it looks like, and the lowest temperature would be about 518. But yeah, I'll give you guys a little bit of time to look over these if you want. That's about it for today's video. I didn't know plastic welding was the actual thing, but it looks like I learned something new today. Thank you guys for watching. Have a great rest of your day.